Hi guys, welcome to audisacademy.net. This is the first in a series of videos which is going to give you everything you need to know in regards to programming a mode system. A mode system stands for Music on Demand Experience, and it's developed by SpeakerCraft, and it's not just an audio matrix or an amplified audio matrix, it's also a multi-zone controller. That's where it gets its name, the MZC, so that stands for multi-zone controller. And so in addition to just amplifying source components and supplying speakers with a amplified audio level, it can also be used to control displays, AVRs, and the actual source components that you're listening to. In this particular video, I'm going to give you an overview of all the components that make up a mode system, how they're wired together, but just before doing that, I'm quickly going to run through SpeakerCraft as a brand and let you know a few firsts that SpeakerCraft have come out with and give you an idea of where they've come from. So, SpeakerCraft came originally out of California, more specifically Riverside, as you can see here on a map. So originally they were a hi-fi dealer based in Riverside. So that's they just had a shop where they sold hi-fi equipment, but they were fairly technical. They came from an engineering background, and there was a need for removing the speaker from its traditional box and placing it in a wall or a ceiling. This was due to it being on a motorhome, and there wasn't as much space for the speaker boxes. Yet there was a requirement for good audio inside that motorhome. So thus the architectural speaker was born. SpeakerCraft removed the cone and the tweeters from a generic sort of box and placed it directly in the wall and the ceiling. This required them to think on their feet and come out with a few sort of firsts. So not only have they just invented the first architectural speaker, they had to develop other technologies in order to make it as much of a success as it is today. Examples of this: SpeakerCraft were the first company to come out with the aimable speaker. SpeakerCraft was also the first company to come out with the DT speaker. DT stands for dual tweeter, so that's a stereo image coming from a single point. The popularity of their speakers in this particular motorhome meant that it was required in thousands of motorhomes, and a production run was needed in order to fulfill that demand. Thus, SpeakerCraft had to develop their own warehouse, and out of this warehouse came many of the brands that I'm sure you'll be familiar with today. SpeakerCraft, however, are the originators. They are the only ones, I believe, with a lifetime warranty. And SpeakerCraft's technology, of which I've just mentioned, such as the DT, the wave plane, which I didn't mention. The wave plane is, if your speaker isn't aimable, SpeakerCraft came out with a way to disperse the audio. This is called the wave plane technology, and it's yet another SpeakerCraft first. There are one or two more SpeakerCraft firsts that I'm going to make you aware of as we go through today's presentation, but they are specific to the mode system. So, as I've just mentioned, all of these brands originally were OEM manufacturers of SpeakerCraft technology, coming out of the same warehouse. But in 1994, SpeakerCraft was born as a brand in itself, and no other brand therefore has the same heritage that SpeakerCraft has. They invented the architectural speaker, and today they are still innovating. The most recent innovation to note is the profile speaker. They've also come out with the best sounding plaster over speakers, and there's even speakers which you could bury in your back garden. That's a in-ground subwoofer called the Boom Tomb. So a very exciting and innovative speaker company, but not all in-ceiling speakers sound the same. Now there's hundreds of models of SpeakerCraft speakers, so I would urge you to get in touch with aldersystems.co.uk. You could email sales@aldersystems.co.uk if you wish to require more information on which speakers will be good for your specific job. If you just want to browse the range, you can jump onto www.aldersystems.co.uk and click on SpeakerCraft and then Architectural Speakers, where you can browse all the specs and read up a little bit more about the different speakers that SpeakerCraft have developed for different applications. I'm not going to go into the specifics of the speakers during this training course, but I'd just like to point out that there are a lot of variations, so you can really fine-tune your requirements or fine-tune the sound and make sure it matches your requirements. So this training course is mainly intended to give you an orientation of the mode system. So the main part of the mode system is the MZC controller itself. of which there are 3 models. The MZC-66 is the current model, but just before going into that, I would like to bring to your attention the other models in the range. Due to the popularity of the mode system, there are hundreds or thousands of these units out there. So it's definitely a very relevant system to learn, as you may from time to time be required to service an older unit such as the MZC-64, which is now discontinued. However, there are still options for trade-ins for people that already have an MZC-64. So you may wish to speak to all the systems in regards to that. But the naming convention here is MZC, stands for multi-zone controller, and the 6.4 indicates that it's 6 source inputs to 4 powered zone outputs. So that's 6 independent sources to 4 powered zones. So that's 8 channels in total of 30 watts RMS. So clearly there's a channel for left and right. Now this is just audio switching to 4 zones. You can daisy chain these with other 64s to give you 8 zones or 12 zones or a maximum of 16 zones. The MZC-66 follows the same naming convention, therefore it's 6 sources to 6 powered zones. So that's a total of 12 channels of 30 watts RMS amplification. But in addition to the audio matrix which is providing you, it also gives you video switching capabilities. This is switching component video, most commonly used today for CCTV. The 66 is the current model, but the MZC-88 is also another unit which you should be aware of as a mode installer. It's an 8-zone system and it shares 8 sources across those zones. Now the additional 2 sources are the integrated FM/AM tuner that's located on the front of the unit. This tuner is controllable and is bidirectional, so that you can control it from a keypad and also see what you're listening to and have live metadata served from the unit to your keypad. The audio and video switching is now 50 watts RMS for the audio, and the video switching works much in the same way as the 66. However, you've got the additional 2 outputs of which you can switch to. So these are, I'm just trying to make you aware of a few of the differences between the models. But now let's have a look at the similarities between the models, or the shared features. From time to time you may wish to have independent bass or treble control for each zone. An example of this may be an ensuite or a kitchen where there's a lot of hard surfaces or tiled surfaces, may produce a more trebly sound. So in this instance you would augment the treble slightly, or attenuate the treble slightly to bring the treble down so that it sounds the sound is more pleasurable in that zone. Now you have fixed or variable line level outputs. So far I've only mentioned the speaker level outputs, but per zone you also have one pre-out which can be set to fixed level or line level. The system is expandable up to a maximum of 32 zones. Now this figure of 32 zones is got to by combining 4 MZC-88s together. It is crucial to note at this stage that you can link an 88 with another 88 to give you 16 zones, but 8 sources supplied to those 16 zones. By linking the 2 together, you do not gain more sources. Now you can link an 88 with an 88, and as it says here, up to a maximum of 32 zones, but you cannot link an 88 with a 66. Also, in addition to that, you cannot link a 66 with a 64. You have to match the model of the unit when you're daisy chaining them to reach more zones. So again, the 64 will only work with a 64, a 66 with a 66, and an 88 with an 88. Now it's fully compatible with the wide range of mode controller keypads. This is what's meant by the MKP, IMKP, Mode 3.1, Mode 3 and ERS1. Don't worry, these part numbers will be explained and there's individual slides for each of these units, so I'll show you exactly what they are and what they look like, and later on in the next video I'll be showing you exactly how to program them. In addition to these means of control, you also have third-party control systems which you could use, such as bitwise controls. I'll be showing you later on as well how to integrate third-party systems. So, the mode system was the first ever system to allow bidirectional control of an iPod. So it was intelligent enough to not only control the iPod, but serve the complete menu structure from that iPod onto the display of the mode 3.1 keypad, or the mode 3, or the ERS 1, or any third-party control system. So this bidirectional control made the MZC an extremely popular unit, and it's still a very commonly used feature. The mode also has bidirectional control of third-party servers in a very similar way. So not only can you control a third-party server, but you can also read the metadata from that device and display it on the keypad. This is similar operation for selected third-party tuners, allowing you to read the RDS information from a keypad, which is the metadata for a radio station, be it AM or FM. Now, the MZC, as I've mentioned several times, is a multi-zone controller. So as a controller, you would expect it to have zone IR outputs, in addition to that as source IR outputs for its sources, but effectively it can be used to generate IR commands internally from the unit and outputted to control devices that are controlled by IR. You also have the option of adding an RSA1, which would give you an RS-232 interface. This could be used to control devices sort of in a one-way fashion, or the RSA1 in itself could be used in a bidirectional fashion, allowing for RS-232 control from third-party systems, such as bitwise controls, or AMX and Crestron. The MZC, this is the MZC-66 that we're looking at now. So it has a lot of connections on the back, but when we break it down, it is very modular. So just learning one source input and output connection, as you can see, duplicates across to all 6 sources, so a lot of the unit can be covered if we just break it down into the individual sections. So let's break it down and first look at the MZC in terms of its audio and video connections. As I mentioned, this is a 66. I can see this because of the naming convention. I have 6 zones, so therefore it is a 66. Also have 6 sources. The first 6 refers to the 6 sources, the second 6 referring to the 6 zones. I know this is a 66 as well because I've also got video outputs and I've got video inputs on my source inputs. So just here we have the source inputs for audio and video. Now you notice there are 2 sets of RCA connections. That's because, as I mentioned in the previous slide, you can daisy chain multiples of these units together. So in that scenario you would come into the input and then loop out to the next device, probably stacked in a rack. So the next device would be just below here, and using phono cables or RCA cables to include the component video, you could loop from one source into your next unit, sharing the audio and video between the units. This is why when you link multiple of these units together, you will not be able to increase the amount of sources and share them across all the zones. So now, in addition to your audio and video inputs and loop outputs, you've also got IR outputs and loop outputs. So that's for linking the IR for controlling source components across multiple zones when daisy chained together. Generally you would use this source IR output to control, say for instance this was a CD player that was plugged in here. I could stick an IR emitter out of here and program the MZC to turn on that CD player when the first zone turns on, or turn it off when the last zone turns off. Now moving on from the source inputs, we have the speaker level outputs, or the zone outputs, of which there are speaker level outputs. So on a 66 you've got the 30 watt RMS digital power amplifier, and just next to that you've got your zone IR output. So this is useful for controlling zone components, such as you may have a screen or display which you want to integrate into the system so that it turns on when the zone turns on, in which case you would stick an emitter or wire an emitter via a Cat5 cable into this output and then extend that across to the room. Often with HDMI matrices such as the Geffen HDMI matrix, you've got bidirectional IR pass-through. So you could wire this into your HDMI over Cat5 balun and extend your IR to your room in such a manner. Now just above your source, your speaker level output, you've got your keypad inputs. Both this and the speaker outputs connect via a Phoenix module, so it's nice and easy to pull them out and put them in. So you could swap, for instance, the keypads between the zones or the speakers between the zones fairly easily. They just pop out. Now you've got the IR input here. That's because you've got IR receivers on the keypads. So you could point a remote at the keypad to control not only the MZC system itself, but the source components. So using the original remote, you could use an IR pass-through system which is inbuilt to control source components, or you could program the MZC to control those source components directly from the keypad perhaps. If you wanted to input IR into the system, this is where you'd do it. You could plug IR into any of these zones and then be able to control the zone from a learning remote, for instance. Now just above your keypad inputs or outputs, you've got your pre-outs. Now this provides you with a line level output. This could be fixed or it could be variable. This is governed by the switch to the right hand side of it. The VC means variable control, or volume control, sorry, and the MVC stands for no volume control. So with the switch in its current position, which is the up position, when I change the volume on the keypad, it will control the level of this pre-out. By switching it to MVC, it will ensure that the level of this pre-out is fixed at all times. Now, as I mentioned, you've got your line level and your fixed level preamp outputs. Now, just up here at the top of the unit, you'll notice you've got a page input, which is useful for maybe an intercom or a telephone, and you've also got a video input, which might be useful for a CCTV camera, which is pointing at the gate. How you switch to this is programmed in the event setup, which is covered in the next video. However, in general operation, you would sense an input coming in the doorbell input and then tell the unit to switch to these either video or audio feeds. Here you've got your video outputs, so your source inputs come in here. Your video outputs aren't on the zone, as you've noticed. You've just got your line level and speaker level outputs and your keypad ports. So the video is routed up to the top right hand side of the unit, where you've got independent video control. So you don't necessarily have to route, say for instance you've got a source video coming in here to source 1, and if you routed it to zone 1, you could decide to route the video to zone 6, yet the audio to zone 1. So it's an independent video matrix over the audio. Now let's have a look at the control options and where the source comes from. So you've got IR being outputted out of the source IR outputs. So this is useful for controlling, say, a CD player or any source that is controllable via IR. And down here in the zone sort of ports, you've got your zone specific IR outputs. So this would be used for maybe piggybacking an AVR, or perhaps turning on a screen or turning off the screen. There's many uses you could have, but if it's specific to a zone, you would really come out the zone IR output. In addition to these two outputs, you have a summed IR output. Now this is also known as common IR output, as any IR that is being outputted via either a source or a zone, or being received via keypad, will come out as common IR. You'll notice just to the right hand side of it, you've got a switch for controlling the gain of this IR output. Say for instance you wish to blast it over to an entire room, you may plug in an IRE5, which is a SpeakerCraft blaster emitter, and in which case you would switch it to high, which would supply it with a little bit more gain, and you'll be blasting IR to an entire room. Alternatively, if you're going over a piece of Cat5 and going quite a far distance, it may be beneficial to switch this to the high position, just so that you pump a bit more power into your Cat5 cable, meaning you get a clearer signal on the other end. As I've mentioned, you've got your keypad ports here. Now, I've shown you that on this unit, these are actually Phoenix modules that can just snap out. However, on a 64 and an 88, these are Cat5 connections. So again, they can just pop out, whereas on the 66, you actually have Phoenix connections. You'll notice here, these need to be tallied up with the punch down terminals on the rear of the keypads. You've got 2 ports of the data. You've got ground, your IR in, and your plus 12 volts. Now, your keypads internally inside the system go onto what's referred to as the data bus. Another point at which you can access this data bus is via the expansion port, and you have two of these expansion ports, and they are labeled port and loop. If I wanted to join multiple MZCs together, this is where I would come to do that. I would wire another MZC into this port expansion output into the other MZC. I can also plug in additional devices into the expansion loop. I'll be covering this slightly later on as I introduce what those devices are. But importantly, in order to upload the programming that I have done to control the unit, or just the programming that I've done for the unit, I would need to plug my laptop in via this control port. There's a specialist DB9 transfer lead that's required in order to do this, but it's effectively a quad mini jack to RS-232. That's then plugged into a USB to RS-232 converter. If you do not have one of these, they come part of the LTM Learn Test Module kit. I'll be talking about this kit a little bit later on, but it's a very vital kit for you to have in your toolbox as a mode installer. So, in addition to these audio and video and control outputs that you have, you've also got contact closure outputs. This could be useful for completing a circuit in order to do something such as automated blind or control a gate. Any time that you want to complete a circuit, you may wish to use these contact closures. They're programmable from within EasyTools, the software you use to program the MZC, and there's a lot of different times that you could cause these to trigger. We'll talk about that more when I get to the actual programming. This is where you sense whether or not a doorbell or something along those lines or anything that provides voltage is either turned on or the doorbell has been rung, at which point you could choose to switch to any of your source inputs, but most commonly people might choose to switch to the phone giving audio from the intercom, or perhaps switch to the video, which is supplying a CCTV feed from the gate, for instance. Now you've got a common status output. Again, that's programmable, but generically people would have that so when the first zone turns on, this now outputs 12 volts, and when the last zone turns off, it will stop outputting 12 volts. This could be used for turning on something like a Bass Power 250. Bass Power 250 is a SpeakerCraft bass amplifier, or it's just a powerful amplifier which is most commonly used for bass due to its power. That's 250 watts RMS. That amp could turn itself off after sort of a certain period of time of not being used, and then it could be powered on by the 12 volts which comes out of this common status out. So when the unit turns on, 12 volts will be outputted from here and then sensed from the Bass Power 250, which will come on accordingly. What we're looking at now is an MZC-88. As you can see, the layout is slightly different, but the key functionality remains the same. So on an 88 you've also got video switching, but you've got the additional two zones. You'll notice on the zone outputs, to save space, there isn't actually the keypad inputs or keypad ports. So in order to connect keypads to the system, you've got to go via the SCSI cable connector to the EasyPad connectors, which is located next to the contact closures, of which there are 4, which is twice the amount of the 66. Now you've also got voltage sensing inputs. This is an MZC-88 feature only. It's not as necessary these days with the 66 because generally you might be controlling it with a third-party control system, so you know the state of other kits in your system. You've also got doorbell and voltage sensing inputs. This is the same as the 66. You've also got your common status output, again the same as the 66. So now that we've looked at the various connections, we haven't looked at the 64. I've neglected to mention that because it's got all the same features as the 66 and the 88, but slightly less of them. So it's 6 sources to 4 zones. I'll just briefly show you here. It's got your 4 zone outputs, you've still got your 6 sources, and you've got no video as we discussed earlier. There's also an RS-232 port here, which is now legacy. This is no longer in use. So if you wanted to get RS-232 into the system, you'd use the expansion ports. So let's now have a look at the generic wiring for a zone. This is our first look at the various mode parts which could be connected. So I've shown you where the keypad ports are, but this is an example of a keypad. This is the mode 3.1 keypad. As you can see, it ships with us around. And this is the mode docking station. So this is the first ever system to allow you to serve metadata around the home. So as I mentioned earlier, you could serve the metadata and control this iPod, but you could see the full menu structure from this keypad. Now these speakers here may be slightly funny looking, reminiscent of an egg poacher, but there is actually a reason for that. These happen to be the AccuFit speakers. So if you're ever looking for a speaker to fit an extremely small cavity void, these are the speakers that you should probably look at. So they connect via 16/2 or 16/4 speaker cable. Let's have a look at what that means. 16/2 means it's a 16 gauge cable over 2 cores, and 16/4 means it's a 16 gauge cable over 4 cores. Now 2 cores are required per speaker. So in this picture, even though there's a white and a red cable running to the speakers, this white is for your left hand speaker, of which there is a positive and negative core of the cable. So you would need a 16.2 just to get the one speaker connected. You might as well run a 16.4 cable and then split the 2 cores to each speaker in the room. This will save you having to run the cable twice. Also more slightly cost effective. Now this is the mode base adapter, which plugs into the expansion port as it handles the data for the iPod, thus allowing this serving of the two-way, or this allowing bidirectional data to be used with the iPod. So you can control it from the MZC, or you could display the metadata on the keypad. So this does not do any audio. These expansion ports are purely data. So in order for me to input audio into the system, I need to run an audio cable out of this mode based adapter. I'll get into the schematic specifically of the iPod slightly later on. But coming out of the zone output, you have your IR output. So this could be routed over a Cat5 cable. It's CDA recommend that the furthest you'll be able to get away with is up to 70 meters. If you wish to go further than that, you may want to go over HDMI over Cat5 balun, of which there probably is one going to the zone anyway. For instance, the Geffen HD-based T Cat5 baluns are capable of achieving up to 100 meters. That's because it's an amplified balun as opposed to this passive solution. Although at the end of this Cat5 cable, there is an AT1, which is a SpeakerCraft amplified terminator block. The amplified terminator block provides you with multiple IR outputs that you can plug into your single zone IR output, thus allowing you to plug in an emitter and put it onto the screen to control the screen itself, or you could control an AVR and piggyback an AVR off of a zone. So what we're looking at here is the rear of a mode 3.1 keypad. So this is a wired keypad, as we can see, because we have punch down terminals. These punch down terminals relate to the keypad ports on the rear of an MZC. It's important that you get these correct. You wouldn't want to wire 12 volts into what is meant for the data on the rear of the MZC. You'll notice that you have an address wheel. This address wheel is for assigning an address to the keypad. This is important, as if you do not sign the address correctly, you may get a message on the screen saying zone setup, which means there is no program for that address in that zone. Now, talking of the address wheel, you only have to set it a unique address if there are multiple keypads in that zone. So say for instance you have one keypad per zone, it would be completely acceptable to have this keypad set to 0 in every zone. It's when you bring multiple keypads into one zone that you need to start addressing the keypads differently, or giving them their own unique address. You can have up to 6 keypads in one zone, meaning on a 66 you could have a total of 36 keypads hung off one system. If you needed more than that, you'd probably look at getting another 66 and daisy chaining more together. Now you'll notice there's also a speaker muting relay. This is or a relay output, which is meant for wiring into a speaker muting relay. This will give you zone splitting capabilities from a keypad. I'm going to get into this slightly later on. It's more of an advanced feature. You have a easy to install trim ring. This comes with the unit. We also have a UK surround that we have developed so that it can fit into a UK backbox. Now, I mentioned we were going to have a look at the mode base connectivity. The mode base is specifically for the SpeakerCraft iPod systems. So there's the mode base. Wires into the mode base adapter via a piece of Cat5 or a length of Cat5, and it wires into the source inputs via phono. So here, as you can see, this is a phono connection wiring into the source input. There's no need for IR because IR is being controlled via the SpeakerCraft mode dock is being controlled via the data bus. So along this connection, it's a Cat5 connection giving you bidirectional data. You do have to wire in this phono cable to the source input as no audio is carried along this Cat5 connection, apart from the connection between the mode base and the iPod. So audio goes up to the mode base adapter where it is broken out and supplied into the source input. You can stack these mode based adapters together to give you a total of 6. So the maximum number of iPod docks you could use is 6, and you could run the cable up to 75 meters before you may begin to experience issues. Be careful when you run the cable, ensure that you keep it away from any sort of power lines, and specifically do not run it in parallel with 240 volts power, as this would probably give you EMI, which is electrical magnetic interference, resulting in a hum. So now that we know how the iPod works, let's have a look at integrating a third-party audio server, such as the mode Jukebox, or now made by iMerge. So this wires, or as you can see, the keypad would wire into the keypad port in the normal fashion, but now we introduce this other component called the RSA1. This is how you get RS232 port connectivity onto any of the MZC models, so be it a 64, 66 or an 88. If you wish to add an RS232 port, this is how you would achieve that. So this RSA1 wires in via RJ45 or Cat5 cable into the expansion bus. Anything that handles data really gets wired into this expansion bus. From there on, you have a RS232 port which wires into the actual third-party audio server. You don't have to worry about such things as baud rate, but you do have to worry about which firmware is on this RSA1. By uploading the correct firmware onto it, you are telling it what baud rate you need, and there is specific firmware for the various applications of which you may wish to use the RSA1 for. The RSA1 is quite versatile in that it could be used for converting IR into RS232 in a standalone fashion. It could be used for third-party integration, or alternatively it could be used for controlling RS232 devices. In this instance, that's what we're doing. We're using it for bidirectional control of a mode third-party audio server. As you can see, there's multiple phono connections wiring into the source inputs here. So in this example, you could have a total of 4. This mode keypad is capable of serving or being served the metadata from this mode Jukebox, or in this picture an Arcam media server. So two-directional control means you can read the track that you're playing and browse by artist name and track title, etc. So say for instance you wanted to expand on that and not only offer the third-party audio server but the mode base the iPod system, there's no reason why you couldn't do so. As it's labeled, the expansion port is labeled loop, which indicates that you can loop these external devices together. So let's have a look at how we do that. As you can see, the media server here is wiring in via RS232, so we've got our two-directional connectivity or bidirectional connectivity. The RSA1 is again wired in via the Cat5. It's wired from the loop port to the port on the expansion here, and then out of the loop, these are slightly in the wrong place, so this Cat5 cable here wires into the port. Out of the loop comes another Cat5 cable running down to the mode base adapter. The mode base adapter is always the last device in a chain such as this. So if you have multiple devices in your chain, you need to put the mode base adapter last. If you're interfacing with a third-party control system, you always want the RSA1 that third-party control system plugs into the first in the chain. As you can see, only data comes in via the expansion bus, and audio must still be routed to the source inputs. So now that we've looked at the various connections, let's have a look at another type of keypad. This keypad is free, not in terms of its cost, but in terms of the fact that it is free to roam about the entire installation. All the other keypads I've shown you, or the mode 3.1 I've shown you in the other slides, wires specifically into a zone. It is therefore a keypad for that zone. It cannot control another zone. As opposed to this mode 3, it is free to roam the entire installation. So when docked, as you can see here, it's docked in an in-wall dock. This will be specific to the zone of which it is docked in. When it is unplugged and then free to roam about, it is capable of controlling all the zones in the installation. However, do bear in mind that when you wish for it to control multiple zones, you do need to program in a mode 3.1 keypad into every zone, regardless of if there is one there. So how does the mode 3 keypad physically connect to the system when it is wireless? It connects via this mode coordinator, because this is data being handed between these two devices. So it's wireless connectivity from the actual mode 3 keypad to this coordinator, but because it's data, it is required that it is wired into the expansion ports. The coordinator will power itself off of the expansion port, although you could power it locally with a power supply. There's fairly good range on it, as it's a Zigbee wireless protocol, outputting at 2.4 gigahertz, and as you can see, it's a very attractive looking sort of keypad. It could be used in wall or wirelessly, and again, even the iPod metadata is served up to it. And the mode 3, due to it being wireless and being able to control any zone, gives you that extra flexibility and gives you more control capabilities than the standard mode keypad. The mode 3 coordinator is how you connect to it. So when the keypad is wireless, it is speaking exactly to the coordinator. When it's wired, it is speaking to the MZC via the Cat5 cable, and it is specific to the zone that it is wired in. It has fairly good range, and the coordinator can be stacked together along the expansion bus. In this picture, you can see the mode tabletop dock, which is now available only in black, but in this picture we have a white one. But the tabletop dock offers the same functionality in that there's actually a RJ45 port on the rear of the unit which wires into your MZC. This dock also powers and recharges the actual mode 3, because obviously when it's wireless nothing is powering it. So in order to charge the batteries that are built into the mode 3, you would simply dock it in this dock, and then the batteries would be charged. There's a little light here at the front of the unit which indicates when the unit is, or the mode 3 keypad is being charged. When this light is no longer lit, it means that the battery is full and the mode 3 keypad is no longer drawing charge from the dock. This dock which you've just been talking about is clearly the tabletop dock, so you would sit that somewhere maybe on a kitchen side or a table, as opposed to this, which is the in-wall dock. Very similar operation. When wired into the zone, it is specific to that zone that it is wired to. When it's wireless, it can control the entire installation. We'll get into the specifics of how you set up a mode 3, but it is crucial that you are made aware that you need a mode 3.1 programmed into the system for every zone, even if it's not physically there. When the mode 3 is undocked, if you don't want it to control a certain zone, you could just not program that mode 3.1 keypad for that zone. So whatever zones have a mode 3.1 in it will show up on the keypad's menu structure and be selectable. If it doesn't have a mode 3.1 in it, you will not be able to control it in a wireless fashion. You'll also not be able to control it even wired into the unit. So to recap on the slide, ensure you have a mode 3.1 programmed for every zone. I've repeated myself a few times here, but this concept in itself repeats itself a few times, as if you wish to control it from a third-party system, you will again need this to be programmed for every zone, and if you wish to control it from the ERS1, then again you need it to be in each zone. And apologies, I mean the EPR one, which is the SpeakerCraft web server. Now let's have a look at some advanced sort of concepts and features of the mode system. This is the EPR one, which is the speaker muting relay, which we briefly mentioned, or I showed you where on the rear of a mode 3.1 keypad in the slide where I showed you the keypad itself. There's a speaker muting relay, which is the two green sort of connections. When they're live, it outputs 12 volts. So the point of this is to be able to connect multiple pairs of speakers to one zone output, yet have independent control or muting capabilities from these keypads. So here's the rear of the keypad, as I mentioned, and here's the two sort of connections that I could make, which when live sort of output 12 volts. So let's have a look at how this is wired. You've got your Cat5 taking you back to your keypad ports. Then here's the EPR1 speaker muting relays. These wire in to these relay outputs, as I've just mentioned, but the speaker cable that's connecting these speakers is wired via these relays. Now the significance of this is, in ordinary operation, on the front of a mode 3.1 keypad you have the volume control, which is a rotary sort of a potentiometer, which when twisted in a clockwise fashion boosts the volume, and when twisted in an anti-clockwise fashion will decrement the volume. Now when you press that volume wheel, it will mute the actual amplifier itself, which means in normal operation, forgetting these EPR1s, if I was to press the mute wheel, the amplifier would be muted. Thus all four speakers connected to it would receive no audio. That's the standard operation of that volume wheel when pressed. However, in this slide here, this is when we split a zone, so we've got a pair in, say, the ensuite and a pair in the master bed. So in this example, it would be programmed so that when you press the volume wheel, 12 volts is outputted along here, making this EasyPad speaker muting relay become active and mute these speakers by breaking this circuit. So when 12 volts is received, audio no longer goes to these speakers. The amp, however, is not muted at this point. The muting has occurred by 12 volts being applied to this EPR1. So by applying 12 volts to the EPR1, no audio is getting to these pair of speakers, but because the amp itself is not muted and no 12 volts is coming to this EPR1, audio is allowed to freely pass to these speakers here. So by pressing the volume wheel here, it would mute these speakers by applying 12 volts to this EPR1, but because the zone itself is not muted and this EPR1 is not receiving 12 volts because I haven't pressed it on this keypad, audio will be allowed to freely flow to these speakers but will be stopped at this point. The same would happen if it happened the other way around. So I could mute this pair of speakers independently over this pair of speakers. A similar, except the opposite, sort of setup can be achieved with one keypad controlling multiple zones. Now, this is a slightly advanced sort of topic. There is actually a complementary video which will demonstrate the programming side of exactly how this is achieved. But let's look at the physical connections that we would need to make in order to make this happen. So what we're looking to do here is wire in multiple pairs of speakers into different zone outputs. I could wire these speakers in parallel, however in this case I wish to link two zones together. So let's have a look at how we would achieve that and control it from one keypad. So as you can see, there is only one keypad, but I've got multiple pairs wired to independent zone outputs. So in order to link them together, I would wire from a pre-out, so that's the pre-out here, I would wire into this source input. I would also ensure that this switch is set to the VC position so that when I adjust the keypad on this rotary volume wheel that was mentioned in the last slide, when I adjust the volume here, the pre-out volume will be adjusted and then fed into this source input. I would then select in the programming zone 2 to only be listening to this source, and using some clever programming I'd make it so that when zone 1 turns on, zone 2 turns on and listens specifically to source 6, thus linking these two zones together and even making them controllable from one keypad. Don't worry if that sounds quite advanced, there is a video which takes the time to explain that at length. As I mentioned, you set the volume control switch to VC, and then both these speakers will be controlled simultaneously from the one keypad. Well, I hope you enjoyed this presentation. For more information, you can email sales@aldersystems.co.uk, where a sales team will be very happy to talk you through maybe a project requirement that you have, or a requirement for some speakers, and you can browse more information in regards to the Mode system and SpeakerCraft themselves and the other brands that Alder Systems do on our website, which is www.aldersystems.co.uk. Alternatively, you can always give us a call to speak to one of our friendly sales staff. So thank you for watching once again, and I hope you will join me in the next slide here on aldersacademy.net.